Today we're talking about metals. Now you may remember from last time that metals were one of our materials, where materials are the things that we use to make stuff. And when we start talking about metals, we want to remind ourselves about what we talked about and what we already know. So first of all, we know that metals are malleable. They can be hammered into a flat sheet or rolled, I suppose. They are ductile. They can be drawn into a wire, and obviously certain metals are better at doing that than others. They can be used to make alloys, where alloys are mixtures, so physical change, not a chemical change. But one of the big things we talked about last time was that metals are crystals. They have a very regular shape within their small structure. And then they also undergo something called metallic bonding. Not to a type of chemical bond as such, but you've got a bunch of atoms in there that hold their electrons fairly loosely, and those electrons can move around from one atom to the other, which is what makes metals good conductors of heat and electricity. And when we talk about metals being crystals, I showed you this series of pictures last time as well. And the whole point was, especially within this last one here, as metals are formed crystals, you get these areas of regular growth or regular structure this way, and then another area where it's is also a regular structure, but it's a different orientation. And that's where we have these boundaries, and these are called grain boundaries because the individual sections are called grains. And people will talk about the grain growth or grain boundaries, and those boundaries will introduce properties. Now sometimes we like those properties, sometimes we don't like those properties. It depends on what we're trying to use the metal for. It depends on what we want that material to be. So if you start looking at those grain boundaries in slightly different ways, and this is maybe a better picture, or this one's three-dimensional, you can see that structure where that grain boundary is, it might be a weak point, but if you have enough of them, perhaps it ends up making the metal stronger. So it all depends on the metal and what we're going to use it for and so on. This is a picture of a sort of head-on shot of a rod of metal that has been cooled, and if you look at the very outside of that, where the grains themselves are very, very small, that's where you had rapid cooling. And then further in, where the grains are now much longer, these long needle-like structures, that's where the cooling was a little bit more slow. So how we make a metal, how we cool a metal, that will influence the grains and the grain boundaries. So even something like that. And we're going to, when we start getting in class and doing stuff like this, we're going to manipulate some of these things with heating and cooling and slow and fast heating and cooling and see what we can do with that. Showed you this picture as well last time when we were talking materials in general. And at the time we focused on the mechanical properties just sort of as an introduction. But if we look at things like here, so we have workability. Well, that's ductile and malleable joined together. Can I work that metal? But if that metal is workable, is it strong? Is it hard? Is it brittle? So, and any one of these properties, brittleness sounds like it's a bad thing, but it's not necessarily bad. It depends on what we're trying to do with it, with what we want that material to be. Do we want it to be tough? So we're going to spend a little bit of time talking about what these properties mean, and because they are important for metals. So when you talk about mechanical properties, as I mentioned, workability is whether it's malleable and ductile. Brittleness is how easy it is to break when a stress is applied. So stress is some sort of force applied on that material. Hardness is will it dent or scratch. So for example, if you have a hammer or something like that, you want it to be hard, because if you're hammering and your hammer starts to dent, not ideal, and you don't want it to be brittle. But certain things, maybe you do want brittleness if it's a safety feature. So if there's something that when stress is applied you want to break so that something more important doesn't break, brittleness would be a good thing. If we keep going, there's elasticity. If you bend something, does it bend back? Plasticity is if you bend it, it doesn't bend back, or if you apply a stress, it won't bounce back. So plastic and elastic are kind of separate things. So you can't have a plastic elastic. Toughness is the amount of energy required before it will break. Certain things, not very tough, other things are very tough. And then there's strength, and that's usually determined by what's called a tensile test, and it gets kind of perhaps less intuitive, but at the point where you can bend it and it stops bending back. So bending it comes back, that's strong, but if you bend it, at what point will it not come back? So that's kind of what we're after there. And then there's the ultimate, where how much do you break? How much does it take to break it? Every material has that. Whether or not you're going to find that in day-to-day use, well, it depends on what you're using. If you're hammering nails, you probably aren't going to break your hammer. You probably aren't going to break your nail. But if you are twisting bolts, maybe you will break a bolt off from time to time. This is more of a pictorial representation of some of those mechanical properties, and there's a couple of others pushed in, but just sort of what it means when you are applying tensile strength, you're stretching it, when you're compressing it, and so on. If you want to pause and look at those a little bit more, that's great. We're going to move on. Okay, there are times where we want to manipulate the properties, where we want to make something more tough, or we want to make something harder or less brittle. So that means we're going to be controlling those properties. One of the options is to make it from different stuff. So if this metal is not very strong, or if this metal is too brittle, maybe don't use it. You can also add different stuff. So when we're talking about metals, we can now talk about alloys. So there's steel, which rusts, and then there's stainless steel, which doesn't. So, and stainless steel is an alloy involving steel and some other things, chromium and nickel, for example. You can also cool it at different rates. Remember back to that picture where there was small grains on the outside, longer grains on the inside, and I said it was from rapid cooling versus slower cooling. Well, if you slowly cool something, larger grains. Rapidly cool it, smaller grains. We're going to talk about these words in class, and we're going to try and do something with those, where there's something called a quench, and that's where you take something hot and you cool it down quickly. Anneal, where you heat it slowly and let it cool slowly, and then temper, and we'll talk about that in more detail when we get there. We can also do something to disrupt the crystal structure. There's something called work harden, and we're going to see what that means. But if you think about a blacksmith hammering away on a horseshoe or something like that, when that thing is still, let's say that horseshoe, when it's still pretty hot, he's going to hammer away for a while, and then he's going to heat it up a little bit more. What happens is something called work hardening. So as you're working something, it'll get harder because you're crunching the grains and you're crunching those grain boundaries around, and eventually you're going to lose, run out of space for moving things around. And then cold work is, well, as it says, we're trying to work on something when it's cold, where you haven't heated it up. So we're going to spend some time looking at not all of those things probably, but looking at some of those things as they apply to metals, how it changes the properties of metals. But we also want to be thinking about well, things like other stuff. So anyhow, I'm starting to jumble my words a little bit. We'll talk about it in class. We'll do some stuff. It may take us a bit of time to get through it all, but hopefully we have a better understanding of metals and what they can do when we're done. Talk to you in class.